The main task that I had to take on in order to complete my report was to compare reading scores for the different SES groups. So that's what I'm going to do now. Reading scores are quantitative, SES group is categorical. So if I look back over here at this chart, I have one categorical and one quantitative. That's the lower right down here. So the graph would be side-by-side box plots. The descriptive statistics would be 5-number summaries for each group, means for each group, standard deviations for each group. And then the confidence interval for inference would be confidence interval for the difference in the two means for reading for one SES group and the mean reading for another SES group. Now, this is a little bit more complex than what you have to do because you're only comparing science scores for public and private. So you only have to get a single confidence interval, a single side-by-side box plot. What else do you have to get? You only need a 5-number summary for public and 5-number summary for private. So what I'm about to do here is more complex than what you had to do. So here's how I get the box plot. Here's the response variable, reading. For you, it's science. The categorical variable for me is SES. For you, it's school type. And then I have the names of the different SES groups. How did I know to make my Y limit 20 to 80? What I do typically is I run boxplot without this, and then I determine what would be a good range for my Y-axis afterwards. So let me go ahead and run this boxplot command. There we see it. And it shows us very graphically that higher SES leads to, at least for most students, not for all because there's a lot of overlap, but for most students, higher SES is associated with higher reading scores. I want to get the 5-number summaries, the means, and the standard deviations for each of these SES groups. We can use the tapply command to get things by group. And so what I'm doing here is I'm putting in the response variable first. The second argument is the categorical variable, the explanatory variable SES. And the third is the function that we want to use in R. So the first one I want to use is the mean function. When I run this, there are the 3 means for the 3 SES conditions. Average for low is 48.3, and it goes all the way up to the average for high SES of 56.5. The next line will get me standard deviations in the same way. And the final line here, the function I'm going to use is summary. What that does is it gives you a 5-number summary. And again, I highlighted it and ran it, and that's not good. So let me do it again. There we go. And so now I've got the 5-number summaries for the 3 conditions. Notice I have some redundancy here because it also gives me the mean in addition to the 5-number summary, and we already calculated those. So we've already got our graph. We already have our statistics, our descriptive statistics. Now what I need to do is I need to acquire confidence intervals. Now you think about the job I have. You don't have this job for your report, but the job I have, I've got to compare low to middle, low to high, and middle to high, okay? So the way I'm going to do that is I'm going to create 3 new variables. Let me go ahead and put up my environment so we can see those variables when they pop up here. I'm going to get 3 new variables, and I'm going to call them low medium, SES low medium, SES low high, and SES medium high. Well, to get those variables, here's what I did. First of all, the subset command is really nice because it allows us to pull out any data we want. So I'm going to pull out only the low SES. So I provide the name of the data set, students. I provide then the what it is that I want to pull out. And I'm saying here to pull out SES that equals 1. Now notice the 2 equals sign. That tells us that we're looking for something equivalent, okay? So I want my SES to be equivalent to 1. Well, what will that do? That will pull out the low SES. So if I now look at low SES, notice I now only have 47 instead of 200. And if I look at SES, every single one of these is a 1. Similarly, if I were to do it for medium, let's do that. I'm going to set SES equal to 2, and if I look at this, sure enough, all the SES are 2, and there's only 95 of them. If I now do high, I get 58 observations, and SES is 3. If you look at the observations for low, medium, and high, that should add up to 200. 58 plus 47, that's 105, plus 95 is 200. So everything went well. But now in this next step, what I have to do is bind the rows together, thus the term rbind, for low and medium so that I can put low and medium all together. So that's what I'm doing here. So I'm going to put low and medium together, low and high together, medium and high. And the way I'll use this when I do my t-test function is that I will put in, if I'm comparing low and medium, I'm going to use the low-medium data set. So my response variable is reading, but just for the low, medium, and group, not all students. My explanatory variable is SES, but just for the low, medium group. Now, if I was doing this for public-private schools, it's so easy because I don't have to do all this extra work. I can just say t-test. Let's say I was going to look at reading for public-private. So this would be students. I don't need any new data set. I can use the one I already have, pull out reading, and then I want to do reading as a function of, that little tilde here stands for as a function of an R, reading as a function of school type. And that will give me the difference, the confidence interval for the difference in means. The difference in means for reading, public school, it's 51.8, private school, 54.2. I look at this confidence interval here, ranges from -6, which would mean that private school could be 6 higher than public. Why? Because it's subtracted, 51 minus the private minus public. So private school could be 6 higher, or public school could be 1 higher. If I was going to talk about that to the public, I don't think I would say, oh, it ranges anywhere from private school being an average of 6 higher to public school being an average of 1 higher. I'd say that they're within 6 points of each other. The averages for public and private school reading scores are within 6 points of each other. That's what I would say. Okay, so let me see what I get when I run mine for low versus medium. It's a pretty similar thing, within about 6.5 points of each other. Okay, within my sample, private being at 51.6 and public being at 48.3. So that's really all I need it to do. And I have to do it, of course, for now, medium high, low high, but you only have to do the one. So that's it. I hope that helps you analyze the difference in means. That's what we're focusing on here, the difference in means of a quantitative variable for 2 groups.